Okay, so now that we're done with kind of the wheel assembly, the ball caster, and the plastic bits, we're going to start doing some of the electrical components. So the first one I'm going to talk about actually is going to be the microcontroller. So the microcontroller we use is an Arduino right here. Hopefully you can see it. So I'm not going to talk too much about what it is. It's not horrible, or the exact parts designation. You can find all of our parts listed as part of our build list online, but this is just going to be kind of a show of where our electrical components are within the base, and as well as the wiring, how we're doing all that. So Arduino microcontroller is just going to go right over here. So we're just going to then, acting as an intermediary between our Arduino and then the XP shield, what we have is just kind of a pretty basic screw shield. It's going to go very nice on top of here. Be sure and be very careful to make sure the pins align, because we've had several problems with those in the past, with pins not aligning, and then the wiring for this is all just messed up. So looks good, and then we're going to put the XP shield just right on top. Nice and easy, nothing too much. So this stack right here is basically going to be communicating with the controller stack that we have, that's going to be controlled by the player driving this guy. And it's just kind of taking the XP packet and then breaking it down to a set of commands for these motors over here. I'm going to take this XP shield off for right now, just so that it'll be easier later to show how the screw shield is wired. So that's going to be put aside. Next big part is the motor driver. So we use a Sabertooth motor driver, and that's just going to basically receive information from the Arduino to figure out approximately how much voltage to be sending to either motor. So, oops. So just for ease of wiring, we like putting the green side of this closer to the edge, because these guys will be receiving these little pronged inputs, and it just makes it a little easier because sidewall will be running right along here. So that one side, the black side, needs more space to work. Can you still see that? That's all. So next part, and really I guess the last real electrical component, is the tackle sensor. So the tackle sensor we have are not available online. These are ones that we ordered specifically to be made by our Professor Brownell. It's essentially an accelerometer that just kind of tells whether or not a tackle's hit the robot with enough force to cause an X acceleration, and then from there, in the code nested in the microcontroller, it will well, it used to say that now it would tell the microcontroller to cut off energy to the motors. Now though, with the new rules, I think now all it really does is it just works with lighting up the lights. So we're just not going to connect it to the Arduino for now. That may change later, but I'll have to review the rules for that. So The tactile sensor is also mounted on top of these standoffs, just so that's not directly on the base plate. And once again, while we theoretically should have 3 points, we're pretending that 4 is enough. And we're pretending that 3 is enough. But close enough. Okay, so that is all of those. We're just going to kind of attach the power and ground for the motors really quickly. So for the motor driver, these just require a Phillips head. I think it goes power. No, wait, no, it goes power ground like that. Just gonna do that real quick before moving on to the next part. So the next part's a little complicated. Yeah, and you'll notice that on the motor driver there's a B+, B-, and then there's M1 and M2. So M1 and M2 stand for motor 1 and motor 2. So, which is why I'm going to be skipping the middle set, because the middle set will come from the battery actually. Well, more or less. That's nice and tight. This is another source of common error during the game. These will start slipping out, so make sure these are done well. Another thing that's fairly common is having these twist, the wires twist, just to get rid of some electrical noise, but I'm not doing that right now. Okay, let's just do some of the wiring from the microcontroller to the Sabertooth as well. So I'm using green to kind of show which wires are feeding from the Arduino to the motor controller. So on the green terminal, there's an S1 and S2 for motor 1 and motor 2. So because of the way our code's written, we're going to attach our S1 and S2 to pins 10 and 11 respectively. So it's kind of easy way to remember that is lower numbers, a lowest number with the lowest number, so on and so forth. So 1's to 10, 2 is to 11. Just gonna say that. Can zoom in. Then another small wire needed, just a small one to go from ground to the ground on this side. So let's take, there's multiple grounds on this microcontroller, so let's just take this one to the corner right here. Let's go to 0V side here. Okay. And that just about covers it from the microcontroller to the Sabertooth. Okay. Now, so the next part of this is a little bit more complicated. So I'm just going to kind of wheel this to the side a bit, so maybe we can focus in on this guy. This is the terminal block right here. This is what's going to be receiving power and kind of splitting up the power from the battery into several other sources. So the first thing we want to do is kind of want to designate a parallel power sides and parallel ground sides. So just gonna also they're fastened down with screws. Thought that's kind of important. We're just going to use these red wires to kind of link 3 of these blocks together. So that's that. Later on, when we put this on the actual base, which will be like right about here-ish, we'll show you how this connects to the battery and to the switch, but for now that's not particularly important. Next part is we're just gonna put together the parts that's going to go to the motor driver. So notice that these have those prongs again, kind of similar, they'll fit right here. So let's just kind of shove them in. Now we're also going to want to have a ground from the ground and power from the Arduino from the terminal block to the Arduino. Looks like I'm missing said wire, so I'm just gonna go create said wire very quickly. Be right back. This should be long enough. Just gonna insert that second one. It doesn't matter too much, terribly, which of these. Please hold.
Saying?
Huh? It doesn't matter too terribly which grounds and which powers connect to what. It's not been a huge deal. So, like, I just like making them symmetrical on both sides, just to kind of, for housekeeping purposes. That, it could also be helpful if in your robots, if you do decide to standardize which sides correspond to what, it would be useful to write them down so that, let's say, if one of your robots breaks down for a little while, it wouldn't take as long to figure out the power and grounds for, and it would be faster to kind of troubleshoot those. So these two are to the Arduino, these two are the motor driver, and this one will eventually connect with the tackle sensor. So these are just going to go in the middle. Alrighty, I think that's all for this for now. So this is my nice little mess of wires here. So I'm going to just bring back my base plate here. So this is going to connect right about here. We have 2 screws that kind of come in from underneath the bottom and up and through it. They're a little okay, so now you're going to watch me kind of put these in the right places. So, just going to leave that through there, that goes there.
Should I zoom in?
You can zoom in a little bit if you want. more or less okay. Then this power, once again, can pretty much go to any ground. So here's a ground here. I'll use. Let's use a smaller. Grounds are all shared, so it's not a big deal. This power is going to go to this V in right here. Oh, it looks like a V in. And then the tackle sensor already has this little clip. So does it connect like that? So now, that's all the electrical components, so we need to put this guy back on. Okay, so that's all the wiring. If you need, you can also go online. We have a little wiring schematic for you to look at. So all this stuff, by the way, is also on the club website. So feel free to take a look at that, so you can just read everything over at your own pace. Also, as far as drive code and controller code goes, all of that's provided, and a way to get your Arduino editor configured so that it's compatible with all of this is also online. Or you can choose just kind of to look at our stuff and then maybe figure out how to build your own. But we have zip files of all of our codes, or all of the pertinent codes, on our website for free to download. So. Okay, back to these guys. Just figure out which sides go to what. So I'll go there. You've already seen how this all comes together, so this isn't particularly important for this step. Also, probably should have mentioned this before, but all of the HDPE parts were cut out using a CNC engraver. So no fancy 3D printing, because with the size of these pieces, a extrusion mold 3D printer would take forever. And it's just not worth the time or the material to do that. Thank you. Okay. Yes. Actually, I screwed up a little bit. These are kind of fixtures for the light plate that I forgot to insert before I pounded this down. So I'm just gonna like pry it open and try to put them on now. Please hold. You're right. Okay. And then this is the light plate, just kind of nicely sits on top of here. It'll actually fit down into this piece right here. But first things first is we need to attach light switch. This is just pretty cheap light switch. Works for up to, I believe, 12 volts DC. But you can buy this one. We also list which part it is exactly on our website. I, however, would kind of recommend going for something a little less fragile. We've had a lot of issues where sometimes we would make a heavy collision with another robot, or sometimes someone would get lazy and decide to kick the switch off, and that will bend. That will actually break this red toggle right here, and so then we have to replace it. It's not the most robust machine that we have here, so going to also have one power thing. So just kind of give it a light tug, see it doesn't fly out. Okay, and then this guy. So the light switch has 3 ports. We have a, you can kind of look, we should have a power, a ACC, and a ground. So ACC is going to be the part that connects to, the terminal block. So I'm just gonna attach it here. Ground is likewise going to attach here. And then we have another line. This is also red. This is power, and it's actually going to connect to the battery itself, which is why we also have a little fuse box on here. Okay, that goes here. That's gonna kind of go underneath here. Put the wires through so we can put this plate on nicely. Okay, that more or less works. And then I'm actually missing, oh look, there it is. Final wire to add is the ground wire that will go to the battery. So we're just gonna try to find a place to put this guy. Find out this wire a tiny bit. Okay, so yeah, there you have it. Let's just pull this through to save a bit of space. So now we have, if we had the battery here, we'd have power, ground, goes right here, battery would sit in this battery plate, and that is pretty much the long and short of it. The rest of it is connecting the side plates with angle brackets, which I'm going to grab really quickly. These are the angle brackets we use, nothing too special. These are just kind of going to go right here, kind of fixing the side plates to the base plate. Not particularly important, so I'm not going to show that right now. You don't need to see how that works because it's pretty self-explanatory. The only other thing that we have left is how the top plate connects to the rest of this. So, bring this guy over here. So this is our top plate. Previous designs had the top plate such that it connected by really long screws that would go down from the top here all the way down to underneath the plate, and then we would put on a wing nut. But in terms of the time we actually have in a game situation, that takes way too long. Like, to unscrew all these and pull it off probably took about, what, 25 seconds. And by the time that's over, then the next play has already started, or the worst case scenario, like, the next possession has started, in which case you're too late. And you've played multiple plays without one person on the field. So we switched them over to these barrel bolt style. So, you know, might have mentioned how those little protrusions were important last time. You can see after I get this top plate on nicely that they extend past the top plate. This is more or less aligned, right? Okay. So the goal of this was so that you can take off the top plate and look more quickly. Oh wait. There we go. Now these bell bolts just slide in. Once they slip through these little holes that we made earlier, and now nice and fixed on, then it doesn't take too long to unshackle them. And ta-da! So, with that is pretty much everything there is to know about the assembly of the standard base. If you have any more questions, you can just go ahead and visit our website, and if you have something that we don't answer on the website, you can probably email the club itself. The email for that would be rfc, all undercased, at nd.edu. So yeah, I hope you enjoyed this video and I hope you found it useful. And until next time.